this is Algebra 1, Lesson 87. We're starting on page 362. We're going to talk about more on the systems of equations and tests for functions. When we solve systems of equations using the substitution method, we often have to rearrange one or more of the equations before the necessary substitution can be done. So if we have RE times DE, which of course is the distance of DE because rate times time equals distance, equals the rate of W times the T of W. So that's the distance of W. Rate of E equals 200. Rate of W equals 250. Time E plus time W equals 9. Find TE and TW. We can substitute already the values of RE and RW into these, but in order to substitute one of the T's in there to solve for the other T, we're going to need to rearrange this final equation so that one of the T's is on one side of the equal sign and the other one is on the other side. So we have TE plus TW equals 9. We move this over. We have TE equals 9 minus TW. And now we can substitute this value for TE. We have RE equals 200. TE equals 9 minus TW, which equals RW, which equals 250, times TW, which we don't know yet. Okay, now we're going to multiply this through and solve for TW. So 200 times 9 is 1800, minus 200 TW, which equals 250 TW. Now we can get all the TWs on one side. And 1800 equals 450 TW. So TW equals 450, 1800 divided by 450. Which is 4. Okay, if TW equals 4 and TE equals 9 minus 4, then TE equals 5. So those would be your answers. Okay, let's try another one. Given the rate 1 times time 1, which of course is distance 1, because rate times time equals distance, plus rate 2 times time 2 equals 360. Rate 1 is 30. Rate 2 is 40. T1 plus T2 equals 10. So now we need to find T1 and T2. So let's solve for T1. So T1 will equal 10 minus T2, right? If I subtract T2 from both sides, this is what we get. Now we can substitute this for T1 up here. So we have R1 equals 30. T1 equals 10 minus T2 plus R2 equals 40 times T2 equals 360. Okay, let's simplify this. This is 300 minus 30 T2 plus 40 T2 equals 360. Okay, we can subtract 300 from both sides and then simplify the T's. So we have 10 T2 equals 60. So T2 equals 6. if t1 plus t2 equals 10 and t2 equals 6, that means t1 equals 4. Okay, now we're going to talk about tests for functions. In our last lesson, we learned that every domain, or every x, can only have one range, or one y, or an equation is not a function. We can determine if a graph shows a function by applying our vertical line test. So on page 363 of your book, we have some graphs. Here's a graph. This is actually the graph of a cosine wave. And here's a graph of a circle. The vertical line test says that if a graph is a function, then any vertical line intersecting the graph will only meet it at no more than one point. Okay? So if we look at the first graph, this is a graph of a cosine wave. And you can see they put vertical lines in various places here. Each vertical line intersects the graph at just one point. And it doesn't matter where you put a vertical line, it's always only going to intersect this graph at one point. So this is the graph of a function. Okay, now here's the graph of a circle. Any line that goes through the circle, that intersects the circle, is going to actually touch the circle at 2 points, here and here, or here and here, or here and here. So for every x, for every place you go to the right or the left, the y is going to touch the circle at 2 places. So although this shows a relationship, it's not a function. Okay, on the next page, we have some examples. Determine if each graph shown represents the graph of a function. So let's look at A. We have this. It looks kind of like a sine or a cosine turned sideways, perhaps. Anyway, it's a nice squiggly line. If for any x between the places where the x's go here, for any x, if we put a line through that x, the line is going to touch it in actually 3 places. There, 1, 2, and 3. 1, 2, and 3. So this is not the graph of a function. Okay, how about this? This is a nice curve. If we put straight lines through each x, then for every x, there's only one y where the line crosses this graph. So this is a function. Okay, here we have a parabola tipped on its side. And for any x, we're going to cross through the parabola 2 times. So this is not a function. So that's the vertical line test. You see you're going to have several chances to try this. And remember, the point is whether for any x, if you make a straight line, if there are going to be more than one y points that touch this graph. If there is only one y for any x that touches the graph, then it's a function. If there is more than one y for that x that touches the graph, then it is not a function. And that is it for this lesson. Try the practice problems and let me know if you have any questions. Thanks.